Hello everyone, and welcome to this latest webinar from IHS Markit titled Approaches to Solving Network Slicing Before 5G. 5G will enrich network slicing, but in the meantime, as we wait for full 5G deployment, operators and service providers must begin to prepare within existing conditions. So today, our panel will explore how 4G network slicing standards will become more complex to handle in 5G and why it is essential to fully understand network slicing development right now. Our webinar is co-presented by IHS Markit and our partners ECI Telecom and Fujitsu Network Communications. My name is Alan Tatara, Senior Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we get started, I want to highlight some features available to you on the webinar today. So the console that you're viewing is completely customizable. You can open, close, move, or resize any of the windows that you have open on your screen and arrange the console any way you wish. At the bottom of your console are a number of application widgets which contain additional features available for you. Make sure you check out the resource list widget where you will find additional material about our topic, including the downloadable slide deck from today's session, as well as other valuable resources, including a special report authored by our own analyst, Michael Howard. And you'll also notice a Twitter widget at the bottom of your screen. This means you'll be able to tweet directly from within the console. And today we're using the hashtag network slicing. We will also have a live Q&A session directly after our presentation, so please remember to submit your questions or comments at any time by using that Q&A box that you see on the left side of your screen. If you encounter any technical issues, just click on that question mark widget and you'll get the answers that you need. Finally, please note that this webinar is being recorded and that the on-demand version will be sent to you within 24 hours. So now let me take this opportunity to introduce to you Michael Howard, who will be leading our discussion today. Michael is a technology fellow and advisor in the Carrier Networks segment at IHS Markit. Michael, glad to have you with us.
Thanks, Alan. And let's get going here. My pleasure to be here, and I'm glad we have all these people online today. We have a, I think, sparkling presentation set of slides that really illuminate what's happening with slicing. I've been tracking SDN, NFV, automation, what's happening with next generation networks for a long time. That's been my bent. And so I'm going to bring a few highlights of my view here. And we have distinguished speakers from ECI and Fujitsu. I'd like to first introduce David Stokes, who's the Senior Portfolio Marketing Manager from ECI Telecom. David, welcome.
Thank you very much, Michael, and good morning, afternoon, evening to everyone on the call. I have to tell you, it's a beautiful day here in the UK, and we're looking forward to a bank holiday weekend, so I'm in a bit of a school holiday mood. But back to the subject. Yeah, I've been working in this area since the early days of 3G, initially on the brand portfolio, no Bs, RNCs, etc. Then I moved on to the backhaul side with initially optical networking and IP networking. Wasn't involved in methods, it evolved its carrier Ethernet definition, triple plate service delivery architecture, etc. And of course 3G and 4G backhaul. More recently, I've been focused on the needs of making IP and optical networks deterministic for strategic industries and critical infrastructures. And that has played really nicely into the next generation transport network that's required for 5G and the next generation that's required going forwards.
Great, thanks, welcome. And David Alabaugh, who's a software solutions architect at Fujitsu Network Communications. David?
Hi, welcome everybody on the call today. It's good to see everybody on. I'm excited to be here to talk about some of this. I've been in the industry for more than 20 years, helping network operators deliver solutions into their network that are comprised of hardware and software solutions. So having concepts like network slicing bring in all of these pieces and further the convergence of things and enable these operators to deliver those solutions is something that I'm really excited about and glad to be here to share today.
Great, thanks, David. And we'll get going. First, I'm going to lay out a few market trends and how network slicing fits into the current milieu of technology changes. We're going to look at problems and challenges and then how to solve those problems and challenges with new options and solutions. We'll look at deployment applications, how operators are planning to use network slicing. We'll have a brief sponsor approach from each sponsor. I'll take us through conclusions, and then we'll have our audience Q&A. Our goal is to have roughly 45 or so minutes of content and then 15 minutes for Q&A. So please do submit your questions as we go along. We welcome them. We may answer them as we go along, but we have a good time at the end to cover them. So let's get going. So first off, I have my definition of end-to-end network slicing. An end-to-end network slice is a logical view of a single physical network that looks and acts like a physical network to the application or user using it. The idea is that the application or user thinks they have their own network and they have control of it and they can operate it. And so the carrier networks are a complex beast. And so to the user application across the many network domains, whether it's access, aggregation, core, transport, across the different layers from 0 through 7, whether it's physical or virtual, over multi-vendor equipment, the slice has its own connections, that is ports. They might be dedicated hard slices, or they might be soft shared ports, soft slices. They have characteristics of their own. That is, of course, you'd expect SLA metrics like latency, reliability, availability, etc., and certainly capacity, that is bandwidth, dedicated even if it's on a shared network. So the main goal of slicing is what? Use a single physical network for multiple use cases and applications. Do we have to wait for 5G for this? No, we need to get started now. So what's the big picture? I see the big picture of what's happening in the industry is the digital transformation is going on, and service providers are moving towards being digital service providers. Now, these notions started before the, quote, digital transformation trend started sweeping the industry. We had SDN and NFV. We have the notion then back 10 years ago of a software-defined, software-controlled network. And with this comes a network simplification. I'll talk more about that, but basically fixed mobile convergence, you have a single network, multiple services. Network slicing is essential. Automation is essential, and that's what we're talking about here. Automation is the key enabler for digital transformation. The industry a year and a half ago has started its own initiative of zero-touch networking involving AI and ML, closed-loop feedback, lots of domains. All of this feeds into digital transformation. The main goals of digital transformation are twofold. The main one is customer interaction, improving the customer experience, and then agile services. So you have to have an agile network underneath in order to build new services quickly, to offer services to keep your customers happy, keep them sticky, keep them involved and part of your customer set. So automation is the key to digital transformation. And for this, slicing is required. We're going to next look at problems and challenges. And I'm going to ask David from ECI to speak first here. David?
Thank you again, Michael. Yeah, firstly, I would say 5G tends to mean all things to all people, actually. Politicians are using it to talk about all sorts of evolutions in the network. So from a transport perspective, the way we're looking at 5G is not just 5G new radio. It's all of the associated services that go with that, the different sorts of applications, but also the multiple types of access technology, 5G new radio for sure, but also other licensed spectrum like 4G, unlicensed spectrum, and indeed fixed networks as well. So the transport network must be capable of connecting all of these types of networks together. And of course, all of these different services, all of these different networks have completely different requirements to each other. So, for example, the transport network must be able to support dynamic IP services for extremely high capacity mobile broadband, for example, and the ability to move virtualized resources around that network, with virtual CDNs, virtual multi-access edge compute, etc. But also that transport network, if the service providers are going to start to address new revenue streams, that transport network also has to allow them to get into new sectors. So start to pick up some of the private networks run by those strategic industries I mentioned earlier. The problem is those networks have extremely precise deterministic requirements on latency, jitter, and reliability. So this transport network needs to be revolutionized, redefined in a way that allows that to happen. And of course, you could build a separate transport network for each of those service types, and it could be optimized for each of those services. However, that would either mean a lot of over-provisioning, or it would mean a huge cost, as a separate network for each service. And this is where the need for network slicing comes into play. You can take, as Michael said earlier, one set of physical and virtual resources and use those for multiple services with multiple different service types. And that is where we look to take the transport network. And in addition, one extra thing. We always think of this transport network as nailed at pipes. This slicing has to be dynamic. These services are no longer dynamic. The way we view using these services are no longer static. So we need to move this network so it's completely dynamic in the way it operates. Again, slicing helps us play in that space.
Thanks, David. And certainly dynamic means automated. You don't want to have people involved. So David from Fujitsu.
Yeah, thank you. So to take that theme and go a little further, the problems that are dealt with slicing aren't entirely new problems. At the root of this is the age-old problem that the services that customers want and need have different requirements, but network operators need to deliver those on a common network infrastructure while delivering the characteristics that the services need, such as bandwidth, latency, reliability, and availability. So operators are rarely in a position to be able to deploy completely greenfield networks. We all know the situation where we have to take the current networks as they are and continue to maintain and evolve them and selectively mature pieces of them over time and build out adding new technology to enhance the overall capabilities while leveraging the capabilities that we already have in the network. So to do that, working on a common infrastructure, the network operators need to be able to provide multiple logical networks across these multiple domains in the network in that common infrastructure. So today, those different pieces are characterized by various SDOs as network slices. Multiple use cases across multiple network domains. The network today is very complex.
Yep.
And
in fact, I was just going to follow up with, yes, today's networks are very complex, and so you're hitting those points well. So thanks, David, and now that's kind of the setup for what are the problems and challenges, what are those new options and solutions. So I'm going to ask David from Fujitsu to take it from here.
Yes. So as we go ahead and move forward to looking at the new enablers in the network, we'll first take a look at the network technologies. So in the networks today, there are a number of technologies that are already available to support hard and soft slicing concepts. There's traffic separation mechanisms such as wavelengths and OTN, the traditional stuff like silent SDH, and packet-based technologies like VLAN tags and MPLS labels. Enhancing some of that packet technology, there's things like packet-based QoS, multi-factor traffic authentication, policing, queuing, and all those things. But those existing mechanisms are continuing to be enhanced. Some of the examples that I think people are well aware of are things like segment routing, which provide flexible encapsulation and policy-based forwarding so that there can be dynamic optimization. Things like time-sensitive networking, where the high priority traffic with very low latency requirements is able to preempt other traffic within a normal packet stream, and things like virtualized routing, where the control mechanisms get pulled out of the network, and we can further enhance the separation and slicing capabilities by putting those control functions within different VMs. We also have enhancements in the management, control, and orchestration aspects of the network. So today we have a lot of traditional mechanisms to provide these services with their commensurate SLAs to deliver those differentiated services. But oftentimes we need to do that in limited combinations and significantly over-engineer certain parts of that network to be able to assure that performance. As we advance in the capabilities for management, control, and orchestration, we're able to be more efficient in these mechanisms. So for instance, we're now able to have control and orchestration across multiple domains, multiple layers, and multiple technologies. We're bringing policy-based optimization and orchestration into play here with things such as multi-layer routing and fine-grained placement for optimization of the location of, especially in this case, VNFs, which are more easily dynamically placed. And finally, we're automating things, and the closed-loop automation allows us to better conduct these operations at large network scales so that we're not dependent upon manual operations and don't have to limit the number of offerings or the scale of the offerings.
So there's a lot of work to do to take into effect all of the technologies involved, the layers involved, in order to make slicing happen. But these are the technologies that we have, and I'm going to ask David from ECI to weigh in on this, slicing in telecom networks.
So, yeah, I mean, just to repeat, I mean, it's worth repeating because some of these things are slightly difficult to get your heads around. Slicing by its very nature is going to be multiple layers across many domains. If you think even just of the 5G network, you're talking about moving across a RAN domain into a transport domain, and then maybe even into the application management domain. And some of those domains will cross multiple different operators as well. So the slicing must be able to work in those environments, but you must also be able to encapsulate and assure the areas you're working in. So to sort of go back to what a slice is at the most basic level, it's a collection of resources and topologies that are logically isolated from each other. Now, that isolation can range from being very high isolation to low or soft isolation. And by high isolation here, I mean where resources are exclusively dedicated, and that will result in multiple or many end-to-end underlay type connections, and you would expect to get no statistical multiplexing of those resources. So it is quite resource heavy to get high isolation. The alternative is soft isolation. You're using shared resources across a converged packet transport network. I mean, you're still allocating those resources just for the individual slice, but on that shared packet networks. So you can get some degree of statistical multiplexing across that network, whether that be in time or over the resources coming in. And this naturally leads to different forms and different technologies to achieve these types of slicing, totally dependent on what you're trying to achieve. So, for example, you can look at hard slicing. So hard slicing, as I said, you're dedicating resources for a particular type of service. The most obvious one to think of here is wavelength as a slice. That obviously gives you that separation of resources, but it's extremely expensive if you don't have the ability to fill that capacity up with your services. A whole wavelength dedicated to one slice. So you can subdivide that at the optical layer using OTN, and that is a great way of achieving hard slicing. Unfortunately, if you're looking to achieve ultra low latency, OTN does add quite a lot of delay to the processing of the service. So OTN is probably not your route to get a hard slice there. And then you're looking towards a packet-based hard slicing approach. Now, whether that be flexi or whether that be dedicated queues, whichever mechanism you use, you're then using a packet-based approach to do that hard slice to permanently guarantee those resources for your use. And then if you look at the soft slicing approach, those soft slices can use the technologies that David mentioned earlier, segment routing, enhanced VPN, to create soft slices which can give you that converged packet transport network. And you can, of course, set those up using the QoS parameters to use statistical multiplexing on the services that run upon them, if you so wish. The key here is it's not one type of slicing per customer, and that's all they're going to do. The reality is, as networks and services evolve, as operators, MNOs evolve the services they're offering, they'll want a different type of slicing for the different type of services they're offering to their customers. So you need to have a toolkit of soft and hard slicing and be able to use those tools as required when required. So you need to have a network in place which allows you to evolve to deploy those tools as you need them. So, for example, you might initially just start with very easy soft slicing for your EMBB services, and then you evolve to put some hard slicing in. In addition, it should be remembered that at the moment, across the world, about 50%, don't quote me on that, is my guess based on experience, but about 50% of the backhaul network is wholesale. So the MNOs are not building it themselves, they're leasing the backhaul from various types of wholesaler. Those wholesalers are not going to go away, they're part of this story, so they need an approach to do this backhaul as well. And the hard slicing actually is a great way for them to start in that space. You can actually hand off a QoS at that level. So within ECI, we refer to this toolkit of soft slicing and hard slicing as hybrid slicing. So basically the ability to deploy the type of slicing you require when you require it.
Well, thanks, David. And, you know, people ask me, well, hasn't slicing been around for a long time? And yeah, the concept of a VPN is a logical slice of a physical network. What's different today and what the effect, the goal of this kind of end-to-end network slicing is to automate it all, to be able to change slices dynamically, to keep people uninvolved as much as possible with setting up slices and tearing them down. So the difference is, yes, slice as a concept has been around for a long time and been used, but now we're talking about in a software-defined network, using orchestration, using different tools here that at a higher level you can set up slices that cross this complex carrier network of multiple domains and multiple layers and multiple technologies, multiple vendors. So let's look at some deployment applications, and I'm going to ask David from Fujitsu to weigh in here.
Thanks, Michael. So, yeah, as you just pointed out, a lot of the concepts around slicing, traffic separation, and delivery of those differentiated services are not really new. Network operators have been doing that for a while, but slicing in and of itself is a new and enhanced way to approach those problems. So it more systematically breaks things down and allows people to guarantee separation and performance. That said, those existing technologies and the existing applications can be deployed more efficiently using these slicing concepts. And that's one of the big reasons why we need to get started on slicing before 5G gets here to be ready for that. So the fundamental approaches of slicing come down to defining network slices, which are the use cases or applications that we are delivering and will deliver in the future, and defining those as crossing multiple domains. Each of those domains is going to be broken down into what's referred to as network slice subnets. And each of these things, the network slices and the subnets, are characterized in blueprints or templates that then contain a variety of resources, both physical and logical, such as VNFs, in fact, right? So those things can be used to better characterize the services that we have today, break those down into those constituent pieces, and manage them more efficiently in an SDN-enabled control and orchestration network to provide that optimization that we need and wring more out of that common infrastructure that we have today. So doing that in today's network is a good thing. Moving that forward and enabling new technologies and new applications is even more important. So here's an example of integrating wireless and wireline transport by bringing layer 2, layer 3 VPNs in a controlled manner. So taking those same slicing concepts that we just talked about, the slices, the slice subnets, and those blueprints or templates, what we could do is take an existing network and add some new technologies, such as virtual routers and segment routing, that overlay into that or augment on top of it. To do that, we're going to define new slice subnet blueprints, and then we're going to work those blueprints into the existing slice blueprints to enhance existing services. So for instance, augmenting the business service offerings with the new technologies we just talked about, virtual routers and segment routing, and also doing things like adding new services. And those services can be services that we'll deliver today, or they could be the 5G type services like EMBB or the other already identified slices that are identified in the standards, or a large variety of slices that I think we're all expecting to start to come out as that 5G applications and networks continue to mature. So all of that is going to be able to be laid out on that common infrastructure, and the approaches of slicing are going to allow us to introduce new technologies and better utilize that common infrastructure.
So one of the underlying principles of automating anything is to tabularize the parameters of what's going on. So certainly to set up blueprints is one method of tabularizing or building tables of what you want to create. But everything has to be parameterized. We have orchestration tools. So all of this would not be possible 3 years ago. We're coming to the point here in the industry where the technologies of software-defined networking allow us now to do this automation, to have a dynamic slice that humans don't have to get involved in, except at the front end to specify the intent of it. So we'll move on next. And David of ECI, what do you see as applications?
So, I think the most important thing about slicing or how we evolve the network is, in fact, the services that it enables you to support and the way it enables you to support those services in a rapid, efficient, cost-effective way. So I agree with David. The ability to have blueprints you can automatically apply to the network is absolutely fundamental in making network slicing a reality. And then in addition to that, things will move rapidly over time. So initially, we know that mobile network operators are just looking to put the new radio out there and then use their existing networks to do that backhaul. Although we have had a number of cases where we've talked to operators who are looking to do the exact opposite, and this is the case we're talking about on this webinar, is where actually their current networks are reaching end of life, and they need to evolve those networks it is a bit ludicrous to evolve those networks today into a way that does not support 5G going forwards. So we see them starting looking at how can they use network slicing techniques to evolve their current network, fixed or mobile, and then start rolling on the new services. So in this example here, this is quite early on in the next 1 or 2 years, you can quite realistically see some early high bandwidth services being the reality in 5G. If you've already started to go down the slicing approach, you can start putting those early high bandwidth services, HD videos, virtual reality, augmented reality. You can start taking those services and allocating a single slice across that network, a high bandwidth slice, in this case, a 50 gigabit eMBB slice across that network, giving you that resource. However, over time, you could see the need to evolve this slice for a given service, so that in this instance in the picture, you see the compute facility at the service facing edge. It makes sense. That's where it is today. And the RU, DU, CU, by and large, are all co-located at the cell site today. However, as those networks evolve, even in this slice, you could start seeing the need to process data closer to the service, closer to the end user. So you could see that MEC functionality migrating into the center, and you could see the need to, an advantage of moving the CU, again, out of the cell site and closer to the core. In this case, you need to be able to dynamically evolve your network so that you can move from just a bog standard backhaul type network, which we see today, to one that has a mid-haul to this converge point and then a backhaul back to the core. So I think what we see is initially we'll start with the network mimicking what we see in and then being evolved over time to allow the movement of functionality across that network. And it's key that the blueprints are able, as David said, are able to be evolved and adapted to support that. You can then look at some more, should I say, hotly debated use cases. And there's a lot of people you talk to who wonder when, maybe even if, delay-sensitive services are likely to be introduced into the network. And here we're thinking about 5G control of drones, remote healthcare, connected cars. And by connected cars here, I'm actually talking about infotainment type systems, systems where the car is able to feed back information to central processing to help traffic flow, give an example of what's going on in the network, and either entertainment being pumped back to that car or traffic, as I say, traffic flow information. I'm not really talking about autonomous vehicles at this point. For me, autonomous public cars introduce a whole host of other issues, most of which have little or nothing to do with technology. So here I'm just thinking about those delay-sensitive services, like the information systems allowing traffic flow to work, for example. All the signalling that goes on the overhead lights. Absolutely key, and it needs to have real-time information. And if they're to work well, controlling the traffic lights, they need to be highly reliable. So in this instance, you need a slice and a connection which is ultra-reliable and also low latency, i.e. the famous ultra-reliable low-latency connectivity, as specified by 3GPP. So to achieve this, in this example, to reduce the delay, the traffic, the data traffic, not the car traffic, to avoid confusion here, the data traffic needs to be processed as close to the end user as possible. So in here you can see the MEC, the CU, and the user plane functionality is located at the customer-facing edge. And hard slicing technology is used in the middle to minimize the delay associated with protocol encapsulation, etc. And that also guarantees deterministic low latency connectivity to be established. However, in some instances, if you're looking at an overall traffic flow on a road system, for example, traffic may need to be backhauled all the way to the core of the network. And it makes sense then to use a hard slice at the optical layer and really push straight down to the optical layer as soon as you can. The reason for this is that the optical transmission can bypass as many of the packet functionality and processing as possible. You can bypass that packet encapsulation, protocol encapsulation, as we said, and you can get back to the core of the network with as near as possible just transmission delay. I mean, obviously there is processing through the network, but this is as close as you're going to get to going distance with low delay. And in some instances, the MECs all need to talk to each other. So you don't often see this drawn, but sometimes you think of the wider network. There's many of these instances I've drawn here, lots of different MECs all around the metro region, and they need to share information with each other. In that instance, you would definitely see an optical DCI type connectivity between these MECs. So that gives an example where I think slicing can massively help in these delay-sensitive services, especially when you compare what's required here and what's required on that EMBB service. Then as a final example, I also talk about business services. In this instance, actually, I just use business services as a placeholder, really, but it's basically, this is for services where the slice needs to support defined and assured availability, and that has bandwidth dexterity and is able to move virtualized resources across the network. So what this really means is taking the full advantage of the SDN capabilities in the network so that you're able to set up a service for a business, put up all of the VNFs that are required to do a service training across that network to offer the service you need, and then to tear down that service as it's not needed, or to dial up and dial down capacity as more or less capacity is needed. You know, the traditional SDN type approach. So this really allows you to take full advantage of your network resources. However, as David and Michael alluded to, this really needs to be done completely autonomously. You cannot imagine someone in the control room trying to cope with dialing up and down the bandwidth, moving VNFs around the network, instantiating them in one place, reinstantiating them elsewhere. That is just not a manual approach. It cannot be done manually. So again, this is a third type of approach where an extremely dynamic network required to follow a service as it moves across the network and as it moves over its needs over its lifetime. So I think here I hope I've shown you three different types of uses for different types of slices and why you might need a mix of soft and hard slicing to achieve this.
And the story I keep hearing and out in the industry as well, and we don't see many actual deployments out in the real world today of network slicing. It is difficult. It is complex. The new technologies are there, and we have to put them together. Different vendors are taking their approaches to use technologies that are available in the industry to effect these different slices of different sorts. And here we have hard and soft slices. There's a lot of different ways to handle it, but basically the industry is still getting it all together. So with that, I want to move on to the next part, and we have our sponsor approaches. And first up is David from ECI.
So yeah, I mean, I think from the earlier what I've said is what is absolutely key is that operators and wholesalers are provided with a toolkit of slicing technologies that allow them to deliver the transport network that is required for their services today and enables them to evolve that transport network over the future. In ECI, we refer to this toolkit as hybrid slicing. And what is absolutely key to allow the service providers to move beyond just offering mobile broadband is that these slices are able to allow them to enter into the market where delay-sensitive services are required, where IoT connectivity is required, which we've not even mentioned here, but also to actually move to a universal services platform where they can roll on the existing fixed network services and also the next generation fixed network services. To achieve this next generation, this next generation slice transport network has to be extremely dynamic. It's got to be movable and evolvable as network needs change. However, it's also got to be extremely deterministic. If it's going to be evolved to support the strategic and critical infrastructure, it must be extremely deterministic. These guys are still using PDH, by the way, so they're not moving anytime soon because they're terrified about not being able to guarantee the delay or latency across their network. To capture these markets, this network must be extremely deterministic. And of course, all the customers, all types, need to assure their service delivery. So in short, this next generation network is ready for use today, could be used today for existing services well before 5G, would have a benefit, but it needs to be dynamic, deterministic, and assured.
Well, thank you, David. And now as we move to David from Fujitsu, I want to remind the audience we've had quite a few questions submitted. Please do submit your questions as we go along. We're going to have some good time to answer those in a few minutes. David of Fujitsu.
Hi, thanks, Michael. Yeah, so we talked before about the different aspects of slicing, the network technologies, as well as the software for control and orchestration to coordinate that slicing. So at Fujitsu, we're attacking both of those segments and tying them together. So we obviously have a long history of capabilities that provide those slicing enabling technologies that we've seen in the network today, both the wavelength through the Silent SDH stuff and into the packet domain. And as we move forward with the Onefinity series of devices that we have right now, we're able to provide disaggregated solutions that allow for both support of those existing technologies as well as easy introduction of new technologies on top of that. It provides optical through cloud-based control of segment routing in those Onefinity solutions that we're putting forth in the network, enabling the solutions that are important today as well as the solutions for tomorrow, both 5G and non-5G. And then, of course, controlling and orchestrating all of that, we have our Vertura portfolio. And Vertura is a suite of products that provides traditional control for legacy network functions, as well as modern control, orchestration, and assurance for both physical networks and virtual functions, as well as the services that ride across those. And these are the pieces that Fujitsu is using to bring slicing into our partner network operators today and enabling those capabilities in the future.
Nice. So a full set of products that will help your operator friends deploy network slicing. So with that, I'm going to run through some conclusions. Please do keep asking your questions, submitting them. So, conclusions. Network slicing for 4G today and 5G tomorrow. Automation's required. I think we got that. There's a lot of elements that contribute to automation. Need to simplify your networks, need to reduce complexity, add network slicing. All of this involves a lot of new technologies, mostly on the software domain, but the hardware pieces have to be able to respond to those software requests. And make no doubt, slicing looks complex here today. As we go forward over time, over the next few years, as 5G, the real 5G arrives, the requirements for slicing are going to increase, and the challenges will increase because there's going to be more requirements. So what we have to do here is point out that it's good to start today. Get going on this. It's not an easy task. It's a long task. And it's critical to being able to support a cost-effective network. In that regard, reducing the number of networks is the most cost-effective move to achieve overall efficiency. Operators know this. A lot of operators are moving in that direction, but very few have a single network on which they run all of their services. But I wanted to point out this fascinating dictum by Bill Gates. He said, automation of inefficient operations multiplies inefficiency. So if you have a lot of networks involved, that's inefficient. So automation of efficient operations multiplies the efficiency. So if you can get towards a simpler version of your networks, namely get towards a single network, that's the biggest bang for the buck that you can achieve. So slicing enables operators to use single network for multiple services. That's the whole idea. Have a single network, whether it's for transportation, factories, business or residential services, wholesale wireless backhaul. There's all sorts of uses of networks, and as we pointed out several times, usually today there's many networks involved, but agriculture, connected car, and I like David's distinction between autonomous cars and connected cars. We've got a lot of years of connected cars going here before we get to the autonomous stage. Drones, yeah, and industrial IoT or Industry 4.0 healthcare, all sorts of applications that networks are used for, and they're increasing every day. So the slicing is the most effective way of getting to using a single network for all of those different purposes. So don't wait, get started today. You can deploy network slicing into your today's network, existing 4G and fixed networks, and get commercial and operational advantages, benefits today. And that can evolve into 5G tomorrow. With that, we're going to move to audience Q&A. Thank you for your attention. We have quite a few questions, and I will get started here. And let me see what, let me pull up in my screen. So here's a question from a major European operator. At the RAN level, how would it work if the user is entitled to multiple slices? Would it lead to multiple radio resources allocated to that user per individual slice? Which David wants to start with that?
I can start with that. Firstly, I'm going to put my hand up and say I'm no radio expert. So this is going to be based on an answer from a transport guy. Yeah, I mean, if you think of a smartphone, and that smartphone, you might be concurrently, or maybe an iPad rather than a smartphone, but you might be concurrently taking a new voice call using 5G new voice. You might be surfing the internet or downloading something, and you might be playing an interactive game which is very delay sensitive. In this instance, you've got three completely different types of service requiring completely different sets of transport parameters. So to run those efficiently, you're absolutely going to need three different sets of network slices for those. I believe, but I need a radio expert to confirm, that you can configure the air interface in 5G to have certain delay and transmission parameters. So you need to tie up the service with the transport slice to the air interface slice at the same time. So you end up with this end-to-end slice that I mentioned. And that is where having an end-to-end orchestration capability, as David mentioned before, that is autonomous to allow the allocation of service to RAN, air interface slice, to transport slice becomes absolutely key.
Good. David Alaba, do you want to comment on that? Shall I go queue up the next question?
Yeah, just to add to that briefly, So I agree with what David said, that it's critical to kind of chain together the slicing segments, those slice subnets we talked about. One thing I didn't touch on before that may be helpful for people as they consider this is that those different pieces of the slices in the templates of the blueprints are able to be defined either as dedicated or shared. And right now, there's great flexibility in how these slices are being defined. There isn't strict patterns that are being called for. So there's some leeway left to the operator, especially as they have different elements in their network, and they can define which pieces are shared and which pieces are dedicated in there. But for instance, in a situation like this, it would be very common to have different things like virtualized CUs that might handle different slices that would have dedication across those slices, even if you might have underlying segments like WDM or transport networks that may be shared across those domains. So the answer is there's no firm answer, but yeah, it's likely that there would be some level of dedication for those different slices on an end user equipment user.
Cool. The next question comes from a distinguished member of the press and highly regarded technical guy with his own patents. The question is, besides an ITUT functional requirements recommendation, which is not implementable, a recommendation, there are no standards for network slicing. That implies that all network slicing deployments will be proprietary for years. Is that okay? So David Alva.
Hi. Yeah. So I think what we're seeing here is, yes, the initial slicing guidelines that ITUT laid down were rather high level and generic. There are some extensions upon that in some areas like 3GPP for some specific workflows and interfaces for management of those. But right now, the blueprints themselves are not strictly defined. There isn't a common set of those that everybody can go to and look up exactly how it's done. But I think we are seeing some convergence in the market. And I think people do recognize some of the danger of what you just brought up there, in that if we have fragmentation across blueprints and implementations, that could lead to difficulties. So there are some open environments where people are starting to converge on some reference designs for those things. So for instance, the 5G blueprint that's being developed within ONAP and other places where there is commonality and cooperation in the industry that are bringing those forward. So it's not strictly standardized right now, but there is kind of a general movement in that direction, and I think there's a possibility that we'll see some standardized reference of those that allow for some flexibility on top of it as time goes on.
Good answer. David Stokes, do you want to comment anymore, or shall I set up the next question?
Just very briefly, I agree with David totally there, but also as the service needs become more apparent, as in real needs, you'll start to see these gaps being closed. I mean, it actually reminds me very much of the early days of carrier Ethernet, and in that instance, MEF invented itself, or came on board to fill the gap to define carrier Ethernet services, which were all over the place. Whether it's an existing standards body accelerates and brings this together and closes it, or some new body comes in, I don't know, but it's going to be driven by the need.
Okay, good. That's the way standards, I mean, for the last 10 years as we move towards software and more, let's say, the industry cooperating together rather than depending strictly on standards for moving technology forward and moving technology for the whole industry forward. This is the way that it's being done now. And this really shows really is a measure of how far along slicing is. You can do it today. It's never going to be easy. There's going to be, as we move through time, there's going to be more and more standard ways of, without actually being a standard, quote unquote, but there's going to be standard ways, common practices, common blueprints that we'll be able to use that in effect are, a standard of sorts. So let's queue up the next question. Is setting up of slice blueprints what the GSMA is currently doing with their generic slicing templates or GSTs? Which David wants to start that one? David Stokes?
I think that's best for David to answer because he's been talking about blueprints. It carries on from his material.
Okay, David Alibaugh.
Sure. So I think that is part of kind of the broad industry move towards, hey, we can't just let this be the Wild West. We do need to come to some convergence. So I do see that as one of the efforts to try to start to converge on some of those and have some commonality there. I understand that's not the only place. It's in the open source projects. It's kind of in process. There's some discussion, some standards bodies. I think MEF has had some activity in this area, although it's kind of still in process from my understanding. So yeah, I think there's a number of things that are pushing us towards let's define what some of these base patterns are, and over time, the community as a whole will kind of converge on what they think is worth commonizing and what they want to keep flexible on.
Cool. Well, here's another interesting question. I'm interested in finding out how you extend the rules of network slicing across global vendor networks where the user sites are global in nature and therefore over multiple underlying provider networks. So this is a multi-provider question, each of whom may or may not have common rules or priorities for slicing at the different layers. David Alibaugh, you want to try that?
Sure. So I'll take a shot at that. So multi-operator environments are certainly a tricky thing, but I do think that as an industry, we're making some progress there. So if you kind of look at a number of the different frameworks for orchestration across multiple operators and service providers, take, for instance, the MEF LSO architecture. There are defined reference points for the business system and orchestration layers, the Sonata and the interlude stuff, and those are leveraging a number of the open APIs from TMF to accomplish that coordination between network operators and even multiple service providers. I know that there's some efforts underway in ONAP right now, for instance, to start to bring in an open implementation of multi-operator exchange using some of the MEF multi-operator standards for services. The way I see this particular application with network slicing evolving is network slicing is a specific way to look at blueprints for services, and the architectures and APIs that I just talked to are enablers to accomplish the coordination and automation across those operator boundaries. So for instance, you would be able to exchange definitions and capabilities for network slices, including the SLAs and the constraints, both at a business layer as well as an orchestration layer, and then you would be able to coordinate that orchestration across those domains using those kind of techniques and some of the standards. It's not a done deal yet, but that's how I kind of see the industry moving in that direction.
Great.
Yeah.
Go ahead.
I was going to say I would agree with that, but there's also we're moving as time goes forward. So where we end up isn't where we start. What I mean by that is we have to solve this problem very quickly because, as I mentioned during my presentation, around 50% of the transport network is from wholesalers. That isn't going to change anytime soon. So by definition, any mobile network is going to be multi-operator because it's going to be MNO network combined with wholesalers network. So there has to be a solution for pretty rapidly for doing this multi-operator in that environment. And we've had a lot of debate about this internally and with various customers. We're starting to see when we're talking to the wholesalers that maybe they would start with some basic easy to define, almost manual hard slicing type approaches where they just provide initially a wavelength or capacity using OTN, and then move to providing packet-based hard slicing across the network. So then the segment routing in the mobile network operator will just see that as a transport resource, although you're running those mobile network operators soft slices over transport vendor operators, hard slices. So you started to move down that route. But in the long term, as David said, this has to be solved. And as people know, we've been quite instrumental in ECI at helping look at the MEF LSO work going there. So that's also very key and fundamental in moving this towards its end goal.
Good. Well, we're at the end of our hour. I'd like to thank the audience for their fine questions, for your attention during the webinar. I'd like to thank our speakers for the great information, very clear, articulate. And with that, I'm going to turn it back over to Alan to wrap up here.
Thank you, Michael, and thank you for leading our discussion today, and thanks to our audience as well for attending and submitting all those questions and comments. The on-demand version of this webinar will be available shortly, so feel free to come back, view the session again, or even pass along to your colleagues. Now, you are going to see a short survey pop up at the conclusion of our webinar, so please take a few moments to fill that out. And lastly, make sure you continue to follow us on Twitter and LinkedIn for information on future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.